Thousands of years ago, early humans stood beneath the night sky and tracked the movement of the stars. We noticed repetition. We noticed sequence. Long before we had equations, we observed the physical world to find patterns in the chaos. We still live by those observations, but the environment has changed. Most of us spend our time in the output layer, reacting to the finished products of software and AI, without ever seeing the back-end logic that dictates how they work. Because we only see these finished results, it's easy to assume intelligence is a natural talent, a fixed gift that some people have and others don't. When we can't see the steps inside the machine, we begin to feel outpaced and intimidated by our own tools. This raises a question for anyone trying to keep up. So, how does an ordinary mind transform into an extraordinary thinker in an era of such overwhelming complexity? When we approach the world as a system to be engineered, we stop reacting and start building. We find that the most complex technologies are actually built on a highly structured landscape of logic. Navigating that landscape requires a single, interconnected ladder of thought. We don't need a million scattered facts. We need to build our understanding one level at a time, from the ground up. That construction begins with first principles. We have to strip away the technical jargon and break every complex problem down to its most basic, undeniable truths. True learning often starts with the act of unlearning. We have to see that logic is simply the process of taking our repeated observations and putting them into a reliable, predictable order. This is why code matters. A language like Python allows us to take that human reasoning and turn it into a durable, repeatable process. This split-screen diagram shows the translation. On the left, a human thinks, I should check the missing values, inspect the columns, and flag the suspicious rows. On the right, code turns that thought into a sequence of explicit mechanical instructions. Automation amplifies the logic you provide. If the underlying reasoning is flawed, the technology will simply scale those errors across the entire system. As we move into the branches of the system, we use mathematics to manage the unknown. Math provides the precision needed to turn vague feelings of uncertainty into exact measurements of probability and risk. Deep learning passes raw data through mathematical filters. In the first layer, the system groups meaningless fragments, like pixels, into basic features. Next, features combine to recognize larger structures. Finally, the network synthesizes these to predict actual meaning, producing a single organized result. When machines solve even more complex problems, they use a tree of thought strategy. They explore multiple possible paths simultaneously and evaluate the results before committing to a decision. Branching buys them time, and evaluation buys them confidence. The most sophisticated AI systems are built by stacking these simple foundational logic layers over and over again. This blueprint represents the full stack of modern intelligence. It is a massive, interconnected ecosystem where raw data flows through mathematical models and into coordinating teams of AI agents. But even at this scale, the machine has a limitation. An AI can calculate, scale, and automate, but it cannot care. It possesses no inherent conscience. This is why the architecture requires a human override. Our judgment and ethics must serve as the final governing layer at the system summit. Thriving in this era isn't about memorizing every new software tool. It's about retraining your own internal mental model so you can reason through the layers of any system you encounter. Extraordinary thinking comes from understanding how these layers serve a human purpose. The construction of that mindset begins with first principles.